Now getting into kind of what monitoring looks like with the total station. So the setup that we just saw is really measuring in a static environment because we're taking a single snapshot in time. So it's a single set of atmospheric conditions, usually one set of backsites, one set of monitoring prisms, and it's just one moment in time. When we're doing monitoring, we're measuring the same series of targets, but just in a dynamic environment. And what that means is anything could be changing on site. Usually what it means is that the atmosphere is changing, so the temperature and the pressure and the humidity and things like that. So the medium that we're measuring through changes. And the thing that we're measuring is often going through some sort of change too. So whether it's going to be a structure, changing with temperature, a landslide, a bridge, a roadway, a railway, whatever it is, we're monitoring it because we expect it to be moving or hope that it's not moving. We want to make sure. So we're monitoring in a dynamic environment, and because we're doing these different rounds of measurements, things are going to be changing constantly. So these are really the things that we're going to think about when we talk about monitoring instead of just standard surveying. It's also worth touching on the two different methods to collecting monitoring data with the total station. We have what's called the semi-automated workflow, which is typically done with like that tripod setup. So this is going to be somebody going out with a total station with their data collector and manually or semi-automated measuring data on the same set of prisms, whether it's going to be once a day, once a week, once a month, whatever it might be. They're going out, setting up the total station, running the resection, and measuring all the monitoring targets and computing displacements kind of based off of some other relative kind of baseline. With the fully automated project, it's a really similar workflow. We're just setting up the total station in the field to run 24/7. That way it's just collecting data at a higher frequency for a longer duration, and nobody needs to be there with the equipment. Regardless of if you do the semi-automated or the manual workflow or the fully automated workflow, it's all going to be the same principles and things that we talk about. So it doesn't matter the method. It's all the same when it comes to total stations and monitoring and surveying. You're going to choose semi-automated or fully automated based on the project requirements. Sometimes it makes more sense to have a semi-automated workflow where somebody's going out, setting up the total station, measuring these targets. That's really going to be for your low frequency or typically lower duration projects, where it makes more sense to, instead of buying a new total station and setting up and having it run all the time, it makes more sense to just go out, set up, measure, pack it up, go home, come back 6 months later and do the exact same thing. The fully automated setup is going to make a lot more sense when there's that high frequency of measurement. The sites are very remote, so they're hard to get to, so the travel time is something to take into account. Time sensitive or high risk, and so if there's going to be potential for rapid failure or essentially high risk for the structure, you're going to want to automate that and make sure that that is running all the time. And then as well, the long duration. So if something's going to last, instead of 3 weeks, it's going to last 3 years, it makes a lot more sense to just set it up, have it run, and call it a day. Some more definitions that we want to get into for monitoring. So when we're talking about things moving in a dynamic environment, we want to think about the region of influence. But really what we think about that is the region that something is moving. So this could be an entire area on a landslide, or it could be an area surrounding a structure that you expect to be influencing the structure itself, but just some sort of region that we expect and want to monitor in. We also are going to have our backsites. So same as the standard survey setup, the backsites are going to be our known points. The difference with monitoring is that we're treating these points as fixed. All of the movements and displacements and velocities and all the results that we calculate based on measuring over time, it's all going to be relative to these fixed backsite locations. It's not a limitation of the technology. It's really a limitation of the math that we use in surveying. So the least squares adjustment, it needs to do this adjustment relative to some sort of fixed point. That way, when something moves, you know what it's moving relative to, so you can calculate a new coordinate and a new displacement. So on top of that, we're going to add all of our monitoring targets. They're going to be within that region of influence or zone of influence. The monitoring targets are also sometimes called foresights. We have the foresight and the backside, or the backside of the fixed point and monitoring targets. These are all kind of interchangeable terminologies, but this is kind of what the standard setup looks like, right? So we have the total station measuring the backsites and establishing its resection every single round. And then it's measuring all these monitoring targets and reporting on some sort of relative displacement from the backsites. I also want to introduce the idea of kind of two different types of zones or regions of influence. One is a region that we think has been static for most of its life, and then it may be moving because it's being influenced by local factors. This is really common to see in kind of construction applications where you have something like a railway or a building that's been in the area for 50 years, never moved, never had any issues, never even really been measured before. And then all of a sudden you're introducing some sort of construction or excavation, boring, drilling, whatever it might be in the area. there's going to be some area around that building or asset or structure that if you're messing with the soil, messing with the foundation, you kind of expect that it might move. And so you're going to monitor to make sure that that influence is not going to cause any changes in the structure. The second kind of type of region of influence is something that is already moving. And we expect that it might be influencing other areas. So this is something like a sinkhole or landslide or a landfill, something that we know is already going to be settling and moving. And we're measuring it to make sure that it's not accelerating or getting worse, or if it's stopping, we need to know how long it stopped for, really understanding the inherent kind of dynamics of the system. So this is kind of a visual example of what that first region looks like. So this is where we have something like our railway, which is this big kind of black bar running through this region of influence. And this has been static most of its life. It was laid and made quite a long time ago, and it's been fine ever since. And then all of a sudden you're introducing some sort of construction or disturbance to the area, and it's within this region of influence. And so you're going to be needing to monitor this structure through here. The thresholds for something like this are typically going to be determined either by site engineers or kind of the natural behavior of the structure. And I'll kind of introduce the ideas of structural variance and taking baselines and understanding how something behaves before construction starts. That way you understand what the displacements actually mean. But the idea here is that this has some sort of natural variance on it, and we want to make sure that that is not changing because of whatever influence in the area. Again, it's really important to establish these baselines and establish an understanding of what happens with the system early on. That way, if there is some change to it, you kind of understand what that means in context. The second region, as I said before, is one that is already moving. So we kind of think about this in terms of a landslide application or something that is already settling, sinkholes, landfills, again, anything that's an already dynamic environment. This one's going to be a little bit trickier because typically you're responding to movements that are already happening. So you're not going to have as much time for baselines as you would on something like a structure that's been there for a long time, where you can set up 3 months before construction starts. This is going to be something like you see cracking in a foundation, you see landslide creep, and so you're putting on these automated systems or these semi-automated systems. You're monitoring it to understand what's happening. The thresholds for something like this are typically going to be determined by the current or expected movements, and you're really going to be reporting on something like velocity because there's already a movement in it, and so displacements aren't going to mean as much as displacements per day or displacements per hour or displacements per year, something like that.